In this video, I want to cover all things application software vulnerabilities, right? Now, all applications have vulnerabilities. It's just the way it is. It's tied into our SDLC framework, which we'll cover in another later video, as we'll talk about some good coding practices. But in this video, I wanted to find some common and what we see as common software vulnerabilities out there in the industry. And the first one here that I want to cover is our buffer overflow attacks. And the concept and the idea behind buffer overflows is basically if we feed too much information into an application, and we have an application here or specific areas of that application, whether it's the memory function, we want to see how that application may handle the overload or the actual buffer of the information. So typically when we have buffer overflows, there's a buffer memory that we take advantage of, and it's the memory function of the application. So if we put too much data into that function or into that buffer itself, so this may be the buffer of memory, and we just feed it with data, right? Who knows however long that data can be. And basically it then overflows into maybe another bit here. So I'm just gonna leave that there blank, because in this area, when the data overflows itself, that's when we can then be malicious, right? So typically with buffer memory, it's typically causing that application to do something, right? It could either one, crash, or we can get malicious with it. So we can actually be malicious. Should it crash, we can then launch or add some sort of payload information to the data once it's overflowed. So executing that attack, we then basically feed it amounts of data, and then we fill up that buffer, right, with data. And then obviously that overflows, and then we can put code in this sort of function here for it to execute. So that's pretty much it. So one, we've got buffer overflows attacks, and the other one is integer attacks. And integer attacks are kind of are kind of similar. They're a little bit different in the sort of the understanding of what they are, but the concept kind of is the same, right? It's filling out that memory or the data. So let's just say here I've got a 4-bit register of data. And the idea behind this is, let's say the data itself is an integer data store. And then the data itself, so integer, and this data can house numeric values. So it's got 0 to 15. So what happens then in that bit of code or that bit of memory? So typically it can support maybe 0 to 15. So we can go 0, 1, 2, 3, all the way to 15. Well, then what happens if we then feed it 25? Or we go negative 25, right? Will it cause that integer memory to then have some sort of function? Will it crash again? Would it allow us to maybe bypass maybe some sort of control or some sort of authentication process that it needs to go through? And that's that could be the reason why if we do a negative connotation or negative value to it, it's basically then giving out or more information out into that it's not intended to do. So in the previous video, we looked at things like the credential leakages. So maybe it's going to give us more information than it is intended to do, right? So that's the whole sort of idea and the concept behind it. It's figuring out, well, if we can overflow the memory or overflow the data points, well, what else can we do with it? Or what's acceptable in terms of how this application may respond? Well, how do we then prevent it? And the first thing I would say is validate the inputs. If our integer fields down here are 0 to 15, well, then only we care about is that 0 to 15 values. Make sure that we cannot add in other values like exclamation marks or text itself. So we cannot add normal functioning text, right? That is the way that we can sort of prevent it, right? So we create that baseline of things of the code, and then we can basically prevent the code of injections from happening. So, it's us to sanitize the data, and then we check to ensure that entering too much or too little data, I'm going to put here too much versus too little. So if we put too much, could be a bad thing. If we put too little, could also be a bad thing. And then you can sort of define what the right requirements look like. Moving on, so over here I've got broken authentication is another big area, and broken authentication means lots of different meanings to broken authentication. Basically, if I just summarize it, it's basically the authentication is not implemented correctly, right? So it may be some sort of authentication with a web page, or maybe with a user trying to authenticate to something, maybe a corporate device, maybe a mobile device, and somewhere along the line, somewhere along that middle there, the authentication process is broken, or the way the application then handles the authentication process. So what are some, I would say maybe the main thing here is our identity and access management processes could be, or implementations could potentially be, impersonated, right? So if we take attacks that could compromise credentials or user data to impersonate other potential users across the organization. So poorly identified or poorly identity and access management controls is a big area for this. So how do we prevent, broken authentication from being in the environment? Well, I'm going to drop this down to 4 areas and we'll talk about it. First part is MFA, making sure that our base controls are set up correctly. So we've got multi-factor authentication, that if we go to a web portal, and not only is there a username and password in that field, but then that's also going to require that user to validate who they say they are with another third party or another third means of access, right? Some sort of smart card, key app, like an authenticator app, or whatever it is. So obviously simple username and password is not enough. We've got another measure, another control, which MFA comes into play. The other area is default creds, right? We remove default, or we try to secure our defaults, right? And that's obviously a methodology that we can go down, or obviously our secure by design and secure architecture, maybe secure defaults. So obviously looking across our infrastructure and ensuring that we don't have creds that, if we go to a website and then we notice we use this site for, management of our devices, and then it's a certain vendor, and then if I can just Google the default creds to that login portal, and then I can log in, well, those default creds should be changed, right? So that may allow someone obviously to bypass the authentication process with those default credentials. Obviously, it doesn't go into the actual authentication process being broken, but it technically falls under the same category that unauthorized person then accesses that application. So just be wary of that as well. The other part down here is weak passwords, right? So ensuring our security policy does have a 15 plus characters, and they get rotated every 90 days. And we've got, none of our internal users use weak passwords, and we're constantly monitoring our internal security controls based on our weak passwords. And finally, we've got login delays. Now, in the analogy that I gave before around rate limiting and things like that, we want to make sure that when users get their password wrong, for example, when they're trying to authenticate to a page or authenticate to a remote desktop, for example, and they've tried it too many times, we want to make sure that there's a amount of delays that, okay, we give the user ample amount of times before they can try again, and that's then incorporated into our security policy. It's then relayed to the users as well, so they obviously know and understand the process of and the logics behind these security risks. And then we can then go away and we can implement failed login delays as well to obviously rate limit those login attempts, that we don't have 300 requests coming in all at once. So that's broken authentication. A few more to cover as I just continue on. We got IDOR, that's insecure direct object referencing, and the ID behind IDOR, and it's a very common vulnerability that's found in a lot of applications and account referencing of values. So I'll talk about this in just a moment. So what this kind of is basically when users can directly access data by referencing values. And I'll give you this as an example. So say we go to a web page, and this web page is xyz.com.au. And then it's got something like account number. And then we've got account number. Oh, cannot spell number. That's not good. Let me just change that up. and then it gives the value of the account number, maybe 1, 2, 3, 4. 2, 3, 4, 5, or whatever that value is, right? So it'll give us the value. So what that means is, so typically, if a user has logged in and they're looking at an accounts number page, does that kind of reference what they're actually looking at? And typically it is. So what would happen is then, if we went to that page function, it allows us to view that account number information that's currently showing up in that URL. So this is the URL of the page. So in chances are with IDOR, what would happen is we can then change the number. So if we then change that 1, 2, 3, 4, 5 value to maybe 2, 3, 4, 5, 6, does that mean we can then view someone else's account number? And typically it could possibly be it. So with IDOR, it's kind of a big vulnerability across, viewing that referencing of information, obviously by the values as well. So kind of a big risk when we talk about, sensitivity and sensitive bits of data. Now, how do we prevent it? Like, what's the prevention mechanisms that we can put in play? I'm glad you've asked, because there's a couple of controls that we can put in place. Number one is we can have an indirect library. And what that means is we can have a library of references that says, well, our value is 1, 2, 3, 4, 5, 6. And the value the URL is going to display is going to be, 2xb129. So basically what that's saying is we're going to take an indirect value, and that value is going to show up, not the actual value that's intended for this account number. So I say account number because it could be a variance of different things, but in this example, I'm using the account number. So one, we can use an indirect referencing table. So reference table. And then that reference table, as it comes in and looks for the data, it'll point this data out, not the actual sensitive data. So that's how we can reference it, and then that data can be put out into the actual URL. And the second part here is, and just disregard this because we are going to be continuing through a few more. And the second part is obviously the access control checks, right? So I'm going to put access checks. So if we are a user and we're logging in, and we're then changing that 1, 2, 3, 4, 5, 6, or the actual value to something else. So we're going to try and impersonate that or add in another bit of value there. Are there actual security controls that are coming through to then validate and not just spit out the information willy-nilly, but do we have actually permissions to validate that this user has access, and are there controls in place that are going to validate and sanitize that data as it comes back, and not just spit up that web page to give us the information that we're now requesting. So access controls are another form of authentication process that we can implement for IDORs. Application handling. So application handling basically just says that anytime applications handle errors, they react in a different manner. And sometimes that could be the intention of the assessment, is to see if we can get maybe error handling processes to spit out maybe database dumps or show sensitive information. Part of that process is defined when we define the errors that occurred to default X, Y, and Z, right? So something that could intend the application to handle in a certain way, we want to then test that out. So again, talking about leakages, data leakage. This is when sometimes we send that GET request out for certain information and it spits out something else like the server IP. Right, and this can sometimes tie into a couple of things. One, from a prevention mechanism, it's because the actual software lifecycle or the software deployment, when I say software deployment lifecycle, because as developers begin coding and as they go through that coding of best practices, sometimes they don't care about the data being leaked out, meaning they haven't taken that into account. It could be a bunch of reasons. Maybe the data sensitivity hasn't been defined, maybe things like that. So we can then define that things like that should be sensitive labeled, should be labeled sensitively, and then obviously not being leaked out. So obviously with poor application handling, this comes along with being validated. The data should be validated and sanitized. Now, if we've got a certain, 16 character box, then those 16 characters should only accept what we tell it to accept, not something else. So it shouldn't accept bash commands. It shouldn't accept Python commands. It shouldn't accept, SQL injection commands, anything like that. So if that's just characters, well, then maybe it's just, A to Z, and that's it. And then we go away, we communicate that to our users that we can only use these sort of commands, and the list goes on. So they're the two sort of areas when we talk about application handling. Let's move on as we're sort of wrapping up this video. So we've got header disclosures is another one. Header disclosures, obviously, as we continue to send information out to web servers, they're going to handle back information. So kind of similar to what I'm kind of mentioning in the previous video, like the previous part where we talked about the application error handling. For header disclosures, obviously, when we go out and we get, I'm just going to not draw it in the prevent side, so I'll just do it over here. So when we send our GET request out to that web server, it's then going to respond back with obviously the host, and then it's going to have, the URL, the domain name, whatever the thing is. And sometimes what could happen is we can put in malicious commands. Maybe it's a bash function. Maybe we're trying to curl some information out or in, or whatever the process may be. So typically with that, we don't want those web servers, be able to enter that data in, right? So we want to validate that host header information. So yes, maybe accepting that GET request could be a process. Does the user have access to certain information? Again, going back to their, the controls, does that user have the ability to request that information? And if so, then that's great. And if not, then it shouldn't be accepted. So are the commands allowed to be run, right? So two, are commands allowed? And if not, then that should be sanitized for our data. So any data that goes in there should be sanitized and not be processed. So meaning we validate the information and the controls and the commands and everything like that before the server goes away and actually processes it. And then finally, as we move over into the last bit of this video, that's information disclosure, right? And that's something that we're mentioning before when we talk about the error handling and application handling. Right, and this is the same sort of concept, right? It's the error in the application that spits out that information, right? Could be database information, could be operating system versions, could be, again, IP addresses are very common where it spits out the private IP address and you get to a web page and it says, or red, and it just gives you server IP address. And you're going, oh, okay, well, that's a sensitive information disclosure, right? We don't want to be seeing that. It could be giving us more information than it's intended to do, and it shouldn't be doing that. So that's how we should be defining that, right? Prevention, again, classifying the data. Make sure that there's data classification happening and everyone is aware of those standards. Now, if people or like the developers are not aware of those data classification standards, chances are it's going to say, well, it's not impacting the application. Well, it is, one, because it's a risk, and two, they haven't been trained. So it is a risk and they need to be educated with our Data Classification Act, right? So how we went away and we've classified the data. Two, our encryption. As the data traverses across the internet, is the data encrypted as it should be, right? So making sure the data is encrypted at rest and obviously in transit. And a very common one that we kind of see as well is debugging. So chances are when developers are left debugging the platform before it goes live and things like that. So remove debugging and test codes prior to development. Debugging options obviously provide us time with error and obviously reporting. So basically with debugging, those options to provide us with the errors of reporting the information could sometimes be sensitive, right? So they could have a bunch of error debugs in here that sort of disclose maybe the functions or the roles or how that application does something. It could be some information that we can then take away and then go, okay, well, this application is debugging in a certain manner, then we can take that away. So as a tester, you want to remove that anytime you do your debugging prior to deployment into production. So that could be something else where the data could also be leaked out, and obviously how to prevent is remove that debugging features. So I hope you found this video useful. We've covered almost 6 areas of common application vulnerabilities. I hope you found this video useful, and as always, I'll see you all in the next video.